In this lecture, we will learn about Smith chart. First, let us understand the importance of Smith chart. Why is it needed and what is it used for? Smith chart was developed by P. Smith in the late 1930s. So what is the significance of the Smith chart? So it's a graphical way to solve microwave engineering problems. So key application of Smith chart is finding how much power that was generated by source, what was actually used by load, and what fraction of that power was reflected. This is very important because without maximum power transfer, the system is not really efficient. So what factors would impact this power transfer? First is the impedance of the load. So we know that impedance and gamma planes are related. So finding impedance of the load, source and transmission line connecting the source and the load. Second is the length of the transmission line connecting source and load. So what is the Smith chart based on? So it is based on the gamma plane. So gamma plane is nothing but based on the reflection coefficient that we have studied earlier. So let us understand some basic difference between the DC circuit and the microwave circuit. So in DC circuits, we use Ohm's law and the basic equation is R is equal to V by I. We can do the same thing in microwave circuits where Z of Z is equal to V of Z by I of Z, where this Z represents the impedance and the small letter z represents the position on the transmission line. So this is position dependent in the case of microwave circuits, whereas in the case of DC circuits it is independent of the position. But solving problems using the impedance equation is very difficult due to mathematical complexity. But solving the same problem using reflection coefficient method is relatively easy. And we know that both impedance and the gamma planes are related. So once you solve the problem using reflection coefficient method, then use the equation which is shown here to calculate the impedance or vice versa. So we can say that the Smith chart is a brilliant way of combining gamma and the Z planes. Smith chart is also independent of the actual impedance of the system. So this is important because irrespective of the impedance of the actual system, Smith chart can still be used. So the system may be 50 ohms or 100 ohms system, and that does not matter because Smith chart can work at either impedances. Finally, it may seem that Smith chart is an old method of solving problems, and now that we have latest software and measurement equipment, surprisingly, even today Smith chart is popular, and even the modern test and measurement tools like network analyzers, simulation softwares still use the Smith charts. So one example that I have given here is that the Keysight Pathwave software, which is simulation software, still uses Smith chart, and even the modern network analyzer equipment still uses Smith chart. At first look, Smith chart looks scary. So what we will do is we will go step by step and arrive at the final form. So Smith chart is basically a chart of all possible gamma values but in polar form. So what is a polar form? Any number represented in this format is a polar form where x is the magnitude and y is the phase of the in the equation. So if we use the same equation to represent the gamma, can be written as follows, where this is the magnitude of the gamma and this is the phase of the gamma. So we can say that this represents the magnitude of the reflection coefficient, this represents phase of the reflection coefficient. Remember that gamma or reflection coefficient is a complex number since gamma is the ratio of the reflected to incident waves, and both these waves will have phase information. Now let us revisit few things. So the whole point is maximum power transfer in the microwave system. And the transmission line model is formed by the basic elements which are R, G, L and C. Out of this, only R and G absorb energy while L and C store energy. So R and G absorb energy. The activity on a transmission line can be represented by ratio of voltage to current or by ratio of reflected to incident wave. So these are the two different representations. So the equation for Z, that is the ratio of V by I, is complicated to be used. This is complicated, while ratio of reflected to incident wave is easy to use. So you don't want to use too many equations, and if you think about in 1930s there were no computers. So what would be the best method to solve such complex equations? So you would use some graphical method, and that graphical method is Smith chart.